Hello and welcome to Supercomputing 2012 here in beautiful Salt Lake City. My name is Jay Muehlhofer and I'm the Worldwide Marketing Executive for Technical and Platform Computing. It's my pleasure to welcome you to this year's IBM Virtual Booth Tour, where our theme is a new era of technical computing, powerful, comprehensive, and intuitive. IBM has a long history of being the market leader in the supercomputing segment with the highest concentration of systems in the top 500 based on both the Power and the System X architecture. One of our big focuses this year is how do we take HPC to the mainstream markets for mid-market companies and organizations with integrated solutions for key customer initiatives such as big data, HPC, analytics, and cloud. One of the key additions to the IBM family is the platform computing acquisition, to provide software for workload and resource management. So again, welcome and enjoy the booth tour this year.
Hi, I'm Matthew Drozdel, Global Storage Strategy Director for IBM, and we're happy to be here in Salt Lake City. As you know, about 50 years ago, IBM developed the first spinning disk, a whole 5 megabytes, and now petabyte class installations are as common as skiers here in Utah. But IBM's never stopped innovating, from 250 megabyte a second, 4 terabyte cartridges, to storage class memory, and even modern new RAID technologies for spinning disk. We're happy here to be able to introduce the IBM storage server models 24 and 26. Our customers have been asking us ways to reduce their cost, increase their performance, and significantly enhance reliability. And IBM's been able to, through the dedicated work of our researchers, bring new RAID technologies to the marketplace, including innovations such as declustered RAID and N+3 data protection, and end-to-end storage protection from the platter to the client, from 200 drives to 200,000 drives. IBM understands that smarter planets begin with smarter data.
Hi, I'm Ed Suffern. I work in Intelligent Cluster Solutions, and today what we're here to talk about is the IBM Pure Systems and how they integrate the workload and all the compute processing power connected to storage for a complete solution. So basically what I have here is I have a compute node. This is an Intel processor-based compute node, and what we end up doing with this is we are able to connect it into a Pure Systems chassis, and in that chassis we provide the network interconnect, and we also provide the storage solution. So the customer has a choice. The customer can buy a pure hardware solution, which is called PureFlex, and the customer is able to tailor his or her application needs to the hardware we provide. So in addition to providing a hardware-based solution where the customer can tailor his or her applications, we also provide a pure applications where we actually integrate the operating systems and the applications into the hardware, so the customer has a turnkey solution where you have compute nodes interconnecting together with all the network and into the storage, so we have a complete solution. Now, even though we provide a complete solution, the customer perhaps has additional storage nodes or an infrastructure that it already has there. With the network interconnect that we have in the Pure Systems, the customer is able to connect to his existing network and interoperate with the Pure Systems or the Pure applications with his current infrastructure and his current applications. And what I'm here to demonstrate is our new offering that we came out with this week at the Supercomputing Conference. We're actually introducing a new set of products for the Intelligent Cluster Solutions. These are actually live demos that are running right now here on the booth floor. You can walk around and see these running. We have a big insights solution right here, which is basically the IBM storage offering for big data. Below that we have a number of IBM X series servers connected together in something called a scale MP, where you have a number of processors really tied together, tightly interworking together so the application runs faster. Even below that we have our iDataplex offering, which basically we're coming out with a higher speed interconnect, InfiniBand interconnect, so the applications will run faster. So we also have a demonstration here on the bottom with the new Intel Phi. I mean, everybody around in the supercomputing show is demonstrating the Intel Phi. What we have here is we have a demonstration running without the Intel Phi. We have a demonstration running with the Intel Phi. So a customer can actually look and see the performance improvement they get when we integrate the Intel Phi with our current line of X-Series iDataplex servers.
My name is Ed Seminaro. I'm an IBM Fellow. I'm responsible for high-performance computing for our Power brand. And I have here today a demonstration that we're putting in place for high-performance analytics in our Power processors. We actually have a new processor that we're just coming out with. It's our Power 7 Plus processor. It goes to 32 nanometer technology from the previous 45 nanometer technology. And we actually have a machine that can run it up to 4.4 gigahertz under normal conditions with improved memory bandwidth and a cache size of actually 80 megabytes per chip. This system is actually such that it enables the Power 7 Plus processor completely in all its capability. From an analytics point of view, we have some benchmarks that we have up on the wall there, that we have industry-leading benchmarks in a lot of areas that apply directly to analytics. One example is GUPS. GUPS is also called Random Access. It's an HPC challenge benchmark. We actually have exceeded the previous year GUP benchmark by a factor of 17 times for a score of 2021. And that's just an example of what this platform can do with all the capabilities it has. It's also a great platform for graph workloads. Another popular benchmark is Hadoop. And in a single rack, we can actually do a Hadoop MapReduce terabyte sort in less than 3 minutes.
My name is Paul Cotius. I'm at the IBM TJ Watson Research Center. I'm the Chief Engineer for BlueGeneQ Research, and I'm an IBM Fellow. And I'm here to talk to you today about BlueGeneQ. It was announced at this trade show a year ago, and since that time we've delivered over 250 racks of electronics to over 20 customers. We have a wide, including 2 massive installations, one at Lawrence Livermore National Lab and one at Argonne National Lab, that are doing just fabulous science. We're really excited about some work that'll be reported on later today on modeling the human heart. So all the aspects of the human heart, the chemistry that's going on, the electro signal, everything, all the physics of the heart are being modeled in real time, so that on a supercomputer we are simulating the heart working with all of its complexity, and we can simulate the treatment of the heart, of arrhythmia in the heart with a drug, and watching what happens to the heart, how it responds to this. It's the ability to do human medicine on a computer in real time. It's just something we're extremely excited about. Another activity that's going on at Argonne National Lab is modeling the dark energy in the universe. So trying to understand, actually it's the dark matter of the universe, trying to understand what models fit what we see. If we change the models, are there observables that we might be able to detect? So in the simulation matter, we might be able to see what we cannot see in other ways. We can only see through gravity. So as an ex-particle physicist, I'm really excited about the ability to bring this kind of computation to the world and do this science at this level that's never been performed before.